this video, we're going to talk about how to determine the rate law for a reaction using data. The first thing we're going to do is make sure we have a balanced equation. And we have our equation here, 2NO plus Cl2 yields 2NoCl. As we can see, this is already balanced here. So next we have our data, which I've already set up. It just simply is the trial number, and then different concentrations of our two reactants, and then we have our rates. So, rate laws have a basic form, and that is K, some constant, times the concentration of your reactants to their order. And this we have to determine experimentally. We can't use the coefficients that come from the equation like we do in some other things in chemistry. So right now I just used x and y's for those exponents, and then we're going to determine what those are using this data. So the first thing we're going to do is we're going to substitute our data into this rate equation. So we'll have three different types of equations set up here for each trial. So for trial 1, our rate was 0.18, and that's going to be equal to our concentration, K times our concentration 0.1 to the X times concentration 0.1 to the Y. We're going to do this again for trial 2. And these are all going to have the same K value. K is a constant throughout the entire problem. Now, in order to determine what all of these constants are, the constants K, X, and Y, we're going to divide these equations by other equations here. So, the first thing we're going to do is we're going to look and see which two equations have matching concentrations for one of the reactants. So you can see between trial 1 and 2, the concentration for NO doesn't change. And you can see for trial 2 and 3, the concentration for Cl2 doesn't change. We're going to use this to our advantage here so that we can cancel out some terms. So we're going to divide trial 2 by trial 1. So setting that up, we get 0.36 equals K times 0.1 to the X times 0.2 to the Y divided by 0.18 equals to K times 0.1 to the X times 0.2 or 0.1 to the Y. Need something one right there. So, when we look at this division, we can see that some things cancel out. These K's will cancel because something divided by itself equals 1. The same thing with these 0.1s to the X's. And that's why it's convenient to make sure you have the same concentration for one of your reactants so it'll cancel out. Now let's rewrite this simplified. So 0.36 divided by 0.18, we're just going to get 2 equals 0.2 to the Y divided by 0.1 to the Y. And there's a handy little algebra trick we're going to be using here, and that's like A to the X divided by B to the X simply equals A divided by B to the X. So we're going to do that here, so that's going to be equal to 0.2 divided by 0.1 all to the y. So if we simplify it again, we'll have 2 equals 2 to the y. In this situation, we just have to determine what y is, and we can see that y has to be 1 for this to be true. These are usually fairly simple because you usually get constants for your x and y values, although you can have decimals and more complicated reactions. But for what you're doing, constants will be mostly what you get. Now we're just going to repeat this process using just trials 2 and 3 so that we can figure out what our x value is going to be. So we're going to divide trial 3 by trial 2. And we always put the larger rate on top. So the equation with the larger rate goes on top. It makes it a lot simpler. So then we're going to have 1.44 divided by 0.36 equals 0.2 to the x divided by 0.1 to the x. And we'll put our k values out front here. And then we're going to multiply by 0.2 to the y times 0.2 to the y, divided by 0.2 to the y. And we're not going to put in what we know for y, simply because we know it's going to cancel, so we don't need to worry about it. So that value cancels and our k cancels. If we simplify that, 1.44 divided by 0.36 gives us 4. So we have 4 equals, and using the same trick we did earlier up here, we're going to have 0.2 divided by 0.1 all to the x, which is just 2 to the x. And like we said earlier, this is pretty simple math here, so 2 to what power gives us 4? And we know x therefore must equal 2 because 2 squared equals 4. So now we know what our x and y values are, and we simply need to go back and solve for our k value. And this is fairly simple because we just need to plug all of our information in to one of the trials. And the easiest trial for us to use is going to be trial 1. Because of the fact that we have 0.1 for both of our rates. So if we do 0.18 equals k times 0.1 squared times 0.1, and we do our math here, we'll get k times 0.001. It's going to equal to 0.18. And if we finish this out, we're going to get k equals 180. So our rate law just means we're going to put all of this information into our rate equation up here. So we're going to have 180 times the concentration of NO squared times the concentration of Cl2 to the first power.